Welcome to Higher Order Functions. After completing this lesson, you should be able to describe the application of functions to data and outline basic usages of higher order functions in Scala. A higher order function is a function which takes another function as an argument that is passed to the higher order function so it can perform work on the container. It typically describes how work will be done on the container. And the function that is passed to it describes what you want to do to the data that exists inside of that container. If I have a collection of values 1 to 5 in a range, I can map over that collection by saying for every number in the collection, add 1 to each value. And that returns to me a new collection of values with every single one of them added by 1. There's another syntax we can use at the bottom of the slide where instead of giving a name for every value that is being used in the function, we instead use the placeholder underscore to represent the value. This is a more succinct syntax, however, it's not quite as readable. We also have the higher order function flatMap. And what flatMap will do is apply the function and then flatten it down one level. In this case, we have a list of strings, and each string in Scala is actually a sequence of characters. So the list is a list of sequence of characters, and two collections are in play. If I map over the list and append a hash to the end of every string, I get a new list with each string and a hash at the end of each one. If I flat map instead, it's going to perform the same transformation where the hash is appended to the end of every string, and then it's going to flatten one level. So the sequence of characters is now broken apart, and we end up with a list of characters. Another higher order function is filter. If we have a list of Scala, Python, R, and SQL as strings, we can return a subset of these values by applying a predicate, a function that returns a true or false condition. In this case, I apply the filter higher order function with a function that says only return those strings that contain the capital letter S. And in this case, I end up with a subset of the original list of only Scala and SQL. Each of the previous higher order functions resulted in a new collection being created for the transformation that was performed. But that isn't something we want to do in every case. We have another higher order function called forEach, which allows us to apply the function in an effectful way, but not return a value. If I have a list of values and I map over that list and provide a function such as println, which is going to merely print out the values inside of the collection, I end up printing the values, but then I have a result that I don't need, and it's a waste of memory resources on the JVM. Instead, I could use the forEach higher order function and apply the println function to it, thus printing out the values and not creating the extra values I don't need. A similarly named higher order function is forAll, but in this case, we're going to look at the values inside of our container and see if any of them meet that condition. Again, this one takes a predicate, much like filter did. If I have a list of values, in this case Scala, Simple, and Stellar, and I say forAll, do all of the values inside of this contain the capital letter S? And I get a result of true. If I provide a value that is not in every one of these strings, I return false. Another well-known higher order function in the functional programming world is reduce. And this is a powerful concept that we see used in the MapReduce world for transforming data to make sense of it. In this case, I create a range of values from 1 to 5, and I want to reduce it such that I add the values together. But what's really happening here is I have an accumulated value for the application of the function each time for each value. And I end up with a value of 15. This is very simple to do, however, it has some drawbacks. First of all, you could use the underscore syntax here for placeholder, but you could use it twice, and that doesn't make it quite as clear what you're doing. Secondly, if you have an empty list, as we see at the bottom of this slide, and we try to perform the exact same reduction, we get an unsupported operation exception because we have an empty list and we're trying to reduce it. This isn't behavior that you want to see in production. The way to get around that is to use the more general fold functions. Again, I create the values 1 to 5, and I say that I'm going to fold left in this case because I don't have an unending stream of data that I'm going to work with. I'm going to give an initial value of 0, and I'm going to perform the exact same transformation where I'm merely adding the values together based upon an accumulated value. You'll notice that I have a case keyword here. Don't worry about that for now. We're going to talk about what that means later on. However, if I do have an operation on an empty list where I try to fold left, in this case I end up with a value of 0 and not an exception. Another well-known function is to provide the product of a calculation of numbers. If I have a collection of values 1 to 5 and I use the product function on it, it's going to multiply them together 1 by 1. So I multiply 1 times 2 to get 2, 2 times 3 to get 6, 6 times 4 to get 24, 24 times 5 to get 120. There's also the exists higher order function, and if I have values from 1 to 5, I can pass in a predicate which tells me whether or not something exists within the collection, and this will short circuit when it finds the first one that meets this condition. I can do an exists asking is there a value for 3 inside of my range, and it will return true. If I ask for 6, it will return false. A similar higher order function is called find. And if I have the values 1 to 5, and I say find the value if I have 3 in my predicate, it's going to return an option of a value because find is making the lack of assertion that I know the value is there. If it is not found, it returns none. Another higher order function that we saw earlier on is group by. I can have my values 1 to 5 and then do a modulus function on them to separate them out by those that are even and those that are odd. I end up with a map of key of a remainder of 1 to those values that were odd and a remainder of 0 to those values that were even. Finally, we have the take while and drop while higher order functions. And in this case, I have my values from 1 to 5. I can use take while to return a collection that only represents the values that meet a predicate. In this case, are the numbers less than 3, and I end up with a range of values of only 1 and 2. If I use drop while, it's going to remove those that do not meet this predicate up until it finds one that does. And in this case, I say the numbers have to be greater than 3 because I'm making the assertion to drop everything until I find a value that is not less than 3. And in this case, I end up with a range of 3, 4, 5. Having completed this lesson, you should be able to describe the application of functions to data and outline basic usages of higher order functions in Scala.